guys? All right, tell me right now, is this, are both equations in standard form?
Yes.
Yes, they are, okay? Are they arranged by like terms in the columns?
Yes.
Yep. Are these both like terms? Are these like terms?
Yes.
And are these like terms? Yes, they are arranged in the right order by the columns by the like terms. So we are good there. Now we look to ask ourselves, can we add or subtract to eliminate either x or y? No, we can't. Because what's really in front of this x that you don't see is a coefficient? A 1. Let's put a 1 there just for our sake, okay? So is there any way that I can add 1 and negative 5 and get 0?
No.
Is there any way I can subtract 1 and negative 5 and get 0?
No.
No. Let's look at our y's. If I take 3y and add 4y to it, I get 7y. That doesn't eliminate my y's. If I subtract 3y and negative 4y, that does not eliminate my y's. I would get negative 1y. So neither of these two variables, by just adding or subtracting, is going to eliminate a variable. Does that make sense? So now we need to move on and focus on that last guideline that I gave you in the notes, which was, once you understand that you can't add or subtract, you're going to have to move on to the realization that you're going to have to multiply to eliminate a variable. So now we have to think about what makes more sense, to multiply to eliminate x or multiply to eliminate y. Well, look at my y's right now. What's the smallest number that 3 and 4 both go into? 12, right? Okay? 3 times 4 is 12, and 4 times 3 is 12. That means that if I had to eliminate my y's, I'd have to multiply how many equations? 2 equations. Do I really want to eliminate, multiply 2 equations if I don't have to? But could I? Yeah, if I wanted to eliminate my y's, I could do that. I could multiply the top equation by 4 and multiply the bottom equation by 3. But what makes more sense to do than eliminate y?
Multiply the top by negative 5.
Exactly. I wouldn't multiply by negative 5, Esme, because then we would just have opposite signs. If we just multiplied by a positive, we would add. Okay? But perfect. So Esme said to multiply the top equation to eliminate my x's. So guys, how many times, 1 goes into 5, how many times? 5 times, right? So Esme says to multiply. She said negative, but she understands that we don't need to multiply by any negative numbers. We can always multiply by a positive. We're going to multiply this whole top equation by positive 5. The whole top equation. Because what we're going to produce is what we call an equivalent equation to x plus 3y equals 1. Okay? They're equivalent equations. It's just I'm multiplying the whole top equation by 5 and getting an equivalent equation. So I'm going to rewrite. I'm going to multiply 1x times 5. What's x times 5 become? 5x, right. Plus, what's 3y times 5? 15y. Equals, what's 1 times 5? 5. So this is now my new top equation. The bottom equation does not change. So just rewrite that as is. So negative 5x plus 4y equals negative what? 24. And now I'm going to do what? Now that I've done the multiplication, I have now gone back to what we learned in 7.3. Now can I add or subtract to eliminate a variable? By doing that one step, I now exactly what I did before in the first 2 examples that we've done. Which variable now am I going to eliminate by adding or subtracting, x or y? Which one can I eliminate by adding or subtracting, my x's or my y's? My x's, exactly. So I'm going to eliminate my x now. I'm going to eliminate x. But what do I need to make sure that I realize about the signs in front of my x's? What are they, same or opposite?
Opposite.
They're opposite signs. So because they're opposite signs, I'm going to do what with everything? Add or subtract? I'm going to add, right. I'm going to add. Everything gets added. Everything, no matter what the other signs are, everything in the whole equation has to be added. So everybody put an addition sign out here. I want you to put it in a box to make sure that that doesn't change. Do not change that addition. Everything gets added, right? Okay, guys. So obviously I already know that I'm eliminating my x's. So 5x plus a negative 5x becomes what? 0. So that gets canceled out. Now, take 15y and add 4y to that. What do you get here? What do you get? 19y, good. Equals, what's 5 plus a negative 24? Negative what? 19, good. And how do we solve for y? What do we do to both sides? Divide by 19. And we get y is equal to negative 1. Now, I've only got half my answer, but obviously I've got my y and I need to find my x. So now I need to go back into one of the two equations to solve for my x. Which one seems to be an easier one to plug it in for, the top or the bottom? The what one? The top, yeah. Much smaller numbers to plug it back in for, and they're all positive. Okay? So again, if you don't want to put the 1 there, that's fine. So now we're going to go x plus, now we're going to solve it, just so you know it, we're solving for x now, is what we're doing now. X plus 3 times what? Negative 1 equals 1. So x plus, what's 3 times the negative 1? Negative 3 equals 1. What do I do to both sides? Add what? Add 3. I get x is equal to 4. And there is my answer to that system of equations. Now let me check it real quick, just to kind of, you have to write this down, let's do it mentally here. What's 4 plus, what's 3 times the negative 1 first of all? Is that negative 3? Is 4 plus a negative 3 positive 1?
Yeah.
Yeah, so that part checks. Okay, so that one checks. Negative 5 times 4 is negative 20, plus 4 times a negative 1 is negative 4, is negative 20 plus a negative 4, negative 24. Yep, so therefore it does check. So I know for 100% fact that I know my answer is right. I know for a fact, without even myself or Ms. Steele was correcting this problem, you already know it's right because you checked it and it worked for both of the equations of the system. Both conditions of the system. Okay, we got one more and we're done. Okay?